Okay, what we're talking about is a rewrite of a chart that I did for you earlier. And that chart was down here at the bottom of this page. And if you look on the notebook file right now, I've left it in. But what I wanted to do was show you that my new one is giving you this chart in a much more simple manner. Do you find this maybe a little bit confusing, folks? Because there's so many arrows?
No,
You like that one? If you like it, use it. Serious. If you like it, use it. If you like this, use it. Okay? Whatever works for you. All I'm trying to do is find the stuff that works, because each one of you has your own desires and things that make sense to you, more or less. And I want you to go with that. But at any rate, let's do a typical kind of a problem. And let's say that I gave you moles. Okay, maybe I ought to just circle the moles. If moles is given, what could I ask you to find? Yeah, we could go this way, or we could go this way. Is there another way we could go? Yeah, we might go down. And what would I have to be able to do the down? What's required? I'm talking about this row now. Whoops, didn't mean to write over that. Okay, let's not write over that. There. Okay, if I were working down here, what is required? A balanced equation. Must have that balanced equation. You can't do this operation without a balanced equation. And it's the mole ratio from the balanced equation. Okay, so if I originally gave you something as ammonia, if this were ammonia and moles of ammonia molecules, and I had an equation that said hydrogen plus nitrogen is going to give me ammonia, and I'd have to have something like this, 3 and 2 to balance. And I gave you ammonia, and I wanted you to find moles of hydrogen required. Moles of hydrogen, please. How do I do that? What's the ratio that's going to let me make that conversion? Okay, 5 moles of ammonia. There you go. Over 1. What's my next fraction going to be? What do I have to have on the bottom? Okay, we do this. We do our moles of NH3. Okay, and that's in a circle. And those two circles are going to wind up crossing out because they will cancel each other. And now I go to my mole ratio. What is my mole ratio of hydrogen, this guy, to the ammonia? What's the ratio? 3 to 2. Yeah, hydrogen to ammonia. Now, the question is, who goes on the bottom? What number? 2. You see, all of this complication goes away because we're just doing a couple of fractions. And what's on the top of this fraction? Come on, what's on the top? Yeah, 3 moles H2, sure. And you can just about do that one in your head, can't you? In fact, you can. 15 divided by 2, 7.5. That's the number. You're done. Done deal. Let's do another one. Probably I'll use the same equation. Back to recording. Now, let's do another problem. Okay, we could do another problem. If we are starting with particles, and let's do particles of, oh, and I got rid of my formula again. Okay, now in this problem, we're going to say I've got 6 times 10 to the 22 nitrogens. How do I change that to mass? How much is that going to weigh? Okay, so what do I do first? What do I do first? First fraction? 6 times 10 to the 22, and this is what? N2s over 1. Okay, and that's N2 molecules. And what has to be down here? No. N2 molecules. All right. Now, how am I gonna make this happen? What's Avo gonna do to help? Okay. How many molecules in a mole? So what's on the bottom? Molecules or mole? Molecules, and it is 6.02. Yeah, 6.02 times 10 to the 23rd, and on the top, 1 mole of N2, same stuff. Okay, now we're not going to take the side trip down below. We're just going to go straight across. So what's our next one? What's on the bottom? What's on the bottom? What's on the bottom? Moles of N2, and we're going to circle that guy. And what's going to be on the top? How do I find it? Come on. What am I going to do with the periodic chart? Oh, N2. Okay, each nitrogen is how much? 14. So we got 28 here, right? 2 times 14. And that's 28 grams equals 1 mole of N2. So what number is going down here with the moles of N2? 24. Oh, 14, 14, 28. Oops. 28. Okay, and so the 28 is going to go down here. That's the, whoops, that's not what goes down there. What goes on there? Okay, 28 grams equals 1 mole. What's the number down at the bottom? 1. And on the top? 28 grams of N2, and I'm done. Run the numbers in my calculator, and I've got it. So I've just done the most complicated, well, not the most complicated. The most complicated would be to go particles to moles. Down here, we're going to change moles of one thing to moles of another, and then we're going to go and continue this way. So we're going to go here. We're going to get our moles, come down to this moles, change it to this moles, and then continue and get the mass. So that's how that kind of stuff works. Okay, in this next problem that I gave you, I started out with a definition of molarity being moles over liters. And then I gave you the same solution that we were doing in the last problem, which was up here. Whoops. Okay, in this problem we started out with 25 grams of salt and 25 milliliters of water. And so you also had to know that 1 mil is equal to 1 gram when we're talking about water. This only works for water. It doesn't work for anything else. In fact, this is the definition of a gram. The definition of a gram internationally, everywhere, is that if you have exactly 1 milliliter of water, you will have a mass of exactly 1 gram. Okay? So that allowed us to change the mils of water into grams of water. Now, the interesting thing that happened here is we just took the 25 mils of water and converted it into water first, or grams of water, and then in this next section, we took the mass of the water over the mass of the water and the salt, and that gave us the percent of water. In the first problem that we did up there, we found the mass percent of the sodium chloride. And in in this one, we came up with a 32.4 for the mass percent of the sodium chloride, and then the mass percent of the water came up to 67.6, and the two added together should have come up to 100%, and they did, because we're talking about what percent of that solution is water and what percent is salt, and the total percentage has to add up to 100. Now down here, the problem was quite different. This time we were asking for molarity, and in molarity, we have moles over liters. And so the first thing that had to be done is we had to find how many liters we had, represented by the 25 mils, which was the given volume. Now the interesting thing that happens in salt and water is that the salt actually winds up going in between the molecules of water. Isn't that cool? And furthermore, since water is a polar molecule, the positive molecules, or the positive ion of sodium, will hook on to one side of a water molecule, and the negative ion, the chloride, will hook on to another water molecule on its opposite side, because water is a polar molecule. So it has a plus and a minus side, just exactly the way a magnet does. And so because it's hugging the water and there's space between the water molecules, it's actually fitting into the what's called interstitial spaces that are there, and winds up not increasing the volume of the water at all. In fact, it actually decreases it slightly. It's measurable, but it's slight. Okay. Now, so the molarity, first thing we have to know is the liters. If we know liters, we've got this part of the molarity fraction. Now we need to find out the moles, and the moles is always the solute, which in this case is the salt. So we have to know how many moles of salt we have, and so we change the salt here. This guy is being changed into moles down here, which is 0.205 moles, and this is the moles of the sodium chloride. And that guy is the solute. I'll get that to look like sodium chloride. Let's try again. NaCl. There we go. That's better. And now that we have the moles down in that calculation, there's our moles right here, and we had our liters that we calculated up here. When we come down to the end, it's just the moles over the liters. Ta-da-da. How can I do that? Anyway, moles over liters. There we go. And bring that back. And so dividing that out, you get your moles per liter, which is molarity. Do this more than once. Okay, we're working on a homework problem from tonight's homework and trying to figure out how to do a percent yield problem. What I've written on the smartboard so far is the given and the find, and I've included the actual balanced equation. Now, in this problem, we're finding out something that you probably didn't have any clue about before, and that is reactions hardly ever go 100%. Even if you have the right ratios of, for instance, the acid and the base, if they are perfectly lined up so that we have 1 mole of the aluminum hydroxide and 3 moles of the hydrochloric acid, we have exactly the right number of each, we're still not going to get 100% reaction. And you're going to see that in just a minute as we work this problem. So we come up with something called percent yield. Percent yield says, hey, I've got to figure out something here about what's going on. If I'm not getting 100% of the stuff turning into product, how much am I getting? Well, we're going to find out. So let's take a look at this more carefully. How many? There's something else that's given. We don't have everything here. What else is given? Sure. Did they give you the amounts of the reactants? They had to.
Yeah, 14.
Okay. Okay, good. We got 14 grams of aluminum hydroxide. And what else do we have?
The actual wait.
No, we got to have how much hydrochloric? No? Oh, okay. They're assuming, then they're saying that you have excess hydrochloric acid. Is that what they said? Okay, and acid fill. Okay. How much is actually going to get eaten up, right? How much of that acid is going to get eaten up if we have 14 grams of aluminum hydroxide? We're going to get 22 grams of aluminum chloride. Okay, so that's going to, what they want to know is the percent yield of aluminum chloride, correct? Yeah?
Yeah.
Oh, okay. So, first of all, we're going to have to turn this guy into moles. We can't figure anything out until we get moles. And what is the mole ratio of aluminum hydroxide to aluminum chloride? What's the mole ratio? That's a balanced equation. Oh, that made our life easier. Okay, that's one calculation we don't have to do, right? So let's get this guy into into moles. That's the first thing we have to do. We have to figure out how many moles we have. So, how much for aluminum? Is it 27?
Yeah, 27.
26.9.
27, okay. Yeah, 26.98, yeah, 27. Let's use 27 for aluminum. And how many oxygens?
3.
Oxygens are going to be 3. 3 times 16, 48. And we've got 3 hydrogens for 3. So we've got 78 grams of aluminum hydroxide. So here we go. Just like always. See, I told you you're going to use this stuff forever. At least till the end of summer. The end of next week. All right, so what do we have down here? Yeah, we have grams of aluminum hydroxide. Okay, and what's that number? 78 grams. And on the top, what do we have? 1 mole of what? Aluminum hydroxide. Okay. Now we've got moles of aluminum hydroxide. How do we get moles of aluminum chloride? What's the ratio?
1 to 1.
Okay. Now, let's go back to something. Looky here. Does this mean anything to you? What did we do? Where did we start? Okay, so for this problem, we started with mass, and we went this way. Did we go to particles? No, we had to come down. No. Right there. We're in aluminum hydroxide, right? AlOH 3. Whoops. AlOH 3. And this guy is coming down here and is still AlOH 3. Now, we're going over here, and we're going to find what? Oh, I did. Shame on me. AlOH, now 3. Okay. And what do we have over here? AL what? No. No, we're getting to different stuff. What is it? AlCl3. Okay. How do we figure it out? Balanced equation, mole ratio. All right, let's go back. And where am I? Wow, got to the right place. Okay, so what do we? This is the step we're doing now. What is it? What's on the bottom?
1 mole.
AlOH parenthesis 3. And on the top, we're going to have, yeah, this is 1 mole. And so that's circled. That's going to cancel. Grams to grams cancel. And we got 1 mole of AlCl3. Now we got to go back to grams. So we got this guy on top, this guy on the bottom, AlCl3, and this is moles. And we got to get grams, right? All right, here we go. We got to figure out the aluminum chloride now. Al27, Cl 3 times, 35.5 times 3. Someone have a number? 106.5. Is that our number? Okay, so we got 106.5. And so we got 0.5 and 1.3, carry the 1.3, 133.5. And so this is our moles, and that's 1, right? Yeah. And up on top, we have the 133. Let's just leave it 133. And this is grams of AlCl3. Now we have to do our calculation. Okay, I don't recommend that you do it this way because you're not going to have your units of measure, but I'm going to just use what I'm doing on the next little part here. I can just get that up for you. Okay, we're going to run these numbers on the calculator, and I want to give you some practice at that. So can we see the numbers okay? There we go. There we go. Okay, so we got 14 on the, whoops, clear, 14 on the top, 78's on the bottom, so we tell the calculator that by the divide sign, and we put in our 78. And the next number that's not 1 is on the top, and so that's going to be a times, and that's 133. And yeah. Okay, so our answer is 23.9, is it not? Okay, so we got 23.9, and that's grams of aluminum chloride. Oops, don't need a parenthesis. AlCl3. And now for our question that was asked, it says, what is the percent yield? Percent yield is how much we got. And by the way, this is the theoretical. This number up here is the actual. And we're figuring theoretical. So, what was that number? 22 grams aluminum chloride. That was our actual over what's called theo. The theo is what we calculate, and that was 23.9. And this is also in grams. Times 100, and we got it. Someone give me a number? Okay, about 92%. That's fine. 92% is fine. And is that a anyway? That's our answer for that part. let's look at this problem in sections. We're supposed to figure out from the actual yield, which is right here. From the actual yield, we're trying to find the percent that this reaction went to completion. And we are able to tell that by, first of all, having a balanced equation. That's what this is all about. That's right for you now. Okay, that's what this is all about. Now, all of this stuff here, this was simply changing first grams of one stuff to moles, and the moles came as a result of this fraction. Moles of the original stuff, the aluminum hydroxide. This guy was our mole ratio from the balanced equation. And if we take that back to the beginning of that chart I showed you earlier, that would represent the little stuff down below. And that's where we are going to do the mole-to-mole conversion. And then doing moles to grams requires the molar mass. And that's going back to moles again, but it's moles of a different, or grams again, but it's grams of another kind of stuff, and that's the grams of aluminum chloride. And that gave us, this is what we call the actual. I'm sorry, theoretical. This is what we call the theo. Then when we went down a little further, we took the theo, put it on the bottom, that's what we calculated. We take the given actual. The actual always has to be given. That's always done by doing an experiment. And that gives us our percent yield. And that takes care of percent